For section 7.2 using StatCrunch, I'm going to go over 3 different examples because they all use StatCrunch in a little different way. The first one is a problem from the book. In a test of weight loss programs, 40 adults used the Atkins weight loss program. After 12 months, their mean weight loss was found to be 2.1 pounds with a standard deviation of 4.8 pounds. Construct a 90% confidence interval estimate of the mean weight loss for all subjects. Does the Atkins program appear to be effective? Does it appear to be practical? So I'm going to go to StatCrunch, and remember from our My Stat Lab, we pick on the StatCrunch from the left toolbar, and we're going to go to the website, and from the website we're going to open StatCrunch, and I've already got a window open here. So we're going to go to T-Stats, one sample, and this time we have summary data. And so we're going to enter in the let's pull this over here so we can see the data. So we want to enter the sample mean, which in this case for this program was 2.1 pounds. And the standard deviation was 4.8, and we had 40 adults. And they want us to calculate a 90% confidence interval, so I'm going to go down here on the confidence interval option. I'm going to change that to 0.9, and we're going to do compute. So here's my 90% confidence interval. So the mean weight loss for the group was 2.1 pounds, and the lower limit on the 90% is 0.82 pounds, and we're going to go up to 3.38 pounds. So for that confidence interval, now think about that. This is over 12 months. Is that really, is it effective? Well, it doesn't include 0, so we know there is weight loss going on. But over the course of 1 year, if we're seeing our participants only losing on average about a little bit more than 2 pounds, with a 95% confidence interval ranging from about 0.8 up to 3.4 pounds, it doesn't really seem like this program is a very practical program for the participants. All right, let's take a look at the next problem that I chose to go over with you. And in this one, the reason I chose this one is because it's got negative numbers, and sometimes we do have negative numbers when we deal with means. Listed below are arrival delays in minutes of randomly selected American Airlines flights from New York to Los Angeles. Negative numbers correspond actually to flights that arrive before the scheduled time. So in this case, having a negative number is a better option because it shows that you arrived before the arrival time that was scheduled. We want a 95% confidence interval, and then how good is the on-time performance. So what I've already done in StatCrunch is I had opened up this blank screen before, blank page, and I put in those numbers. Let's click down here. I went ahead and I put in those arrival time numbers down here, and this time, and the reason I chose this again is number one, you had to enter the data, and then number two, when we go to T-Stats, one sample, and this time we're going to be using, let me pull this over so you can see the commands. We're going to be using data. So my data is in the arrival delays column, and they want us to do a 95% confidence interval, so I'm going to scroll down here and select the confidence interval. All right, so my 95% confidence interval for the arrivals, and the mean of the arrivals is negative 9.2 minutes. Now again, remember that means they arrived on average at 9 minutes ahead of schedule, and it ranges from negative 24.3 minutes up to 6.0 minutes. So the question here is, what is to say about on-time arrival? Well, the confidence interval includes 0, and so it's actually telling us that these planes are doing pretty well. They're really not being delayed very much, and in fact, if you look at the data, I minimize this for a second, and if you look at all the data here, remember negative numbers are good numbers. The positive numbers are the late flights. There's one late flight here. There was only 3 out of the group that we were given that were actually late. So it looks like the on-time performance is pretty good. And then the last data set problem I chose to work on is using one of the data sets, and it's using the chocolate chip cookies data set, and they want you to do a 95% confidence interval estimate of the mean number of chocolate chips in Chips Ahoy regular cookies and then in the Keebler cookies, and then compare the results. So I'm going to go ahead and again, this time from the StatCrunch website, I want to go to select the data sets from the textbook. And when I go to the data sets, I want to go to the cookies, which are down here. And I'm going to, let me go back and look at the instructions here. They want a 95%, and we want to do the Chips Ahoy regular and then also the Keebler. So Chips Ahoy regular and then Keebler. So T-Stats, one sample with data, Chips Ahoy regular and then the Keebler, and in order to get a second variable there, use Control-Click, and we want to do a 95% confidence interval. And then what's nice is these are going to show up right above one another. So if we notice Chips Ahoy regular, the mean is a little bit less than 24 chips per cookie, and the range went from 23.1 up to 24.8. Pretty tight interval, actually. 39 cookies. For Keebler, on average, 30.4 chips per cookie. Confidence interval 95% goes from 29.2 up to 31.6. So it looks on average like the Keebler cookies have more chips per cookie, which might be helpful for a consumer to know when they're trying to decide between which two cookies to purchase.